Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge. Third question, reverse odd levels of the binary tree. So as per the name of the question, here you can see that it simply refers to that we are required to reverse those levels of the binary tree which are odd in nature. So it is pretty much clear what they want to say in this question. But another thing which is there is that we are required to check that how they are recognizing each level. Is the starting level as 0 or 1? That will decide that which level we are required to reverse. So here, first let us read this question, that what it exactly want to say. Then we'll go ahead. So, given the root of a perfect binary tree, reverse the node values at each odd level of tree. So, for example, suppose the node values at the level 3 are this, and then we are required to reverse them in this order. So, return the root of the reverse tree. So, basically we are required to reverse them in such a manner that they are reversed in the tree itself. That is, we are not required to return the answer separately. We are required to make the modification in the original tree. A binary tree is a perfect if all the parent nodes have 2 children and all leaves are on the same level. So basically, they want to say that here we are given with a perfect binary tree, and in that perfect binary tree, the property is like this, that each parent would be having exactly 2 children, and at each level, the leaf nodes would be at the same level. Means the last level of the nodes which are being there, they all would be filled up. That's they want to say. Now comes the next part, that the level of a node is the number of edges along the path between it and the root node. So what they want to say is this, that this is the level. Means it is the path from root to that level, then from this level. So here we are at the 0 level, here we are at the 1 level, here we are at the 2 level. So here the thing is that what we are doing here is that here the first level which is being there, it is noted by 0 because that is the point where root is there. So from there only whatever the next would be there, so that will be noted at the 1. So here you can see that 1 is the odd level, so that's why we are required to reverse this level to like this. So that is the thing. So this is the whole thing which we would be doing in this. So as you can see that here what we are doing is we are doing everything as per the levels, right? So it would be preferable to use BFS because in BFS we do level order traversal. So what we would be doing is at each level we would be going, and at that level we would be storing all the nodes in a particular temporary vector or something, right? And then we will reverse them, and how we will be reversing them would be, that reversal would be in that manner that, see, let me explain you, that when we are at this level, right, so we would be storing this node and this node, right? So at every level we would be storing its children nodes, right? But the reversal will take place at that moment only when we reach that odd level. Then we will be starting with the reversal portion. So here, when we are at this node, so we will take what is the last node at this level. So that is this one. So we will basically interchange these. So that's the thing which we will be doing, and that we can do with the help of a temporary vector. So that's how we will be reversing. So the thing would be, rather than using that n log n solution, we could do all of this in order of n only, but the extra space which is being there is of that, what we say, that temporary vector which would be there, and the q which would be there. But the q is by obvious use because this is the BFS solution. So this was the overview for this particular question. Now let us go ahead at how we can solve this. So now comes the next part, how to code the solution. So here you can see that I'm basically using level order traversal for this particular. So this is the basic level order traversal, where at the starting if there is no root, then we will be returning null because we are required to return the tree node, right? So that's right. And then we are taking the queue, and in this queue we will be pushing our first node which is our root itself, right? So, and at the starting our level is basically -1. Why I'm taking here as -1? Because I'm incrementing at this point. if I would have been incrementing after my for loop, then I would have taken this particular level as 0 only. But as I'm incrementing when I'm entering the loop, so that's why I'm taking it as -1. So that is the scenario here. Now here we are taking two vectors. One is values vector and one is temporary vector. Why we are taking two vectors? The thing is that this values vector, that from that vector we will be helping out us with the reversal of our nodes, and this temporary vector, it would be refreshed at each moment when we enter this while loop, and it will be storing all the values at the next level which is about to come, and we will be extracting values from this temp at that moment only when there is an odd level. So that's why we are taking two vectors. Now let us go ahead. So how we are finally doing our question. So this is the standard BFS, that while our queue is not empty, so here this is extra which we have taken, temporary vector is refreshed, and then here taking the size of the queue, so that till this much size we will be able to traverse our nodes, right? And then we are incrementing our levels, and then here int I equals 0, I less than length, I plus plus. So basically what we are doing here is, we are at that particular level, whatever nodes are there, so that would be the parent node, right? So whatever child they are having, they would be pushed to our queue. So that's why we are taking this. And now this is a standard BFS step, and this is also standard BFS step, this is also standard BFS step, and this is that point which we are required to do for reversal. See, if our current exists, right? So at that moment we will be pushing our node to a queue as well, and we will be pushing our node's left value to our temporary vector, and same goes for this rightmost subtree also. And then if our level is basically odd level, then in that context what we will be doing is, we will be not here swapping but assigning. Basically whatsoever value we are having at the current node, that value would be reassigned with the help of our values vector which is being there. And like this only we will be doing this step at every moment when we are encountering the odd level, and at the end we will be, means when we exit out from this for loop, then we will be assigning the value of temp which is being there to our values again, right? And then when our while loop again runs, so temporary vector would be refreshed again, and then it would be ready to store new values. But if the level is odd level, then only we will be taking values from this values vector, as we won't be taking. So that's the whole criteria of this question. As you can see, this whole question, and at the end we are returning the root, because it was required that at the end we are required to return the tree, right? Now here the context is that we are basically using order of n solution, because we are doing this BFS and nothing else is being here which is giving out us any other sort of time complexity. And the space complexity is basically order of n. It is because of this temporary vector which is being there, and also because of the queue which is being used, and also because of the values vector which is being used. So all of them give us 3n. But the thing here is that 3n, right? So it is basically 3 times n only. So that's why it max is n only. So this was all for this particular solution. If you like the explanation, please do like and subscribe to my channel, and please do share among your friends as well. So this was all. So let us move towards the next question of today's contest. But this is all for now. This is all for this video. So yeah, thank you.